G'day all, my name's Luke Krois. I'm the Technical Services Superintendent at the Fosterville Gold Mine. I've been there for about 7 years and started as a geologist and a geotechnical engineer in the early days and worked through to become a Senior Rock Mechanics Engineer and started in the Tech Services Super role about 2 years ago. So I think that the presentation was going to be titled Ground Support and Mining Methods at Fosterville, but I've just gone along with a Fosterville update, and we'll cover a bit of the history, a bit of where we're at, a bit of the global picture, and then maybe a few of the initiatives that we've seen over the last couple of years at the mine. Someone with their phone, it's ringing. Who's that? All yours. All right, so history of the Fosterville Gold Mine. There's a couple of main phases. There's the historic phase, which started in 1894, went through to 1903. Which consisted of the original discovery and historical mining of about 30,000 ounces. These are the old oxide, about 30 to 40 metre depth open pits, and a couple of small shafts as well. 1991 through to 2001 was the second oxide phase, I guess, where open pit operations recovered about 285,000 ounces. And I think they recovered them over about 26 pits over 2 lines of load on the lease. More recently, from 2001 to 2003, we drilled out the resource beneath the oxide pits and identified the sulphide host. The BFS was completed in 2003 with some positive results, and construction and open cut mining commenced in April 2004. The first sulphide gold was poured in May 2005. And in April 2011, we poured our 500,000th ounce, which is an excellent effort. We went underground in 2006, putting in a decline in the base of our first sulphide pit, and our first stope was taken in December of 2006. The initial open cut mining ceased in December 2007, so we spent 3.5 years deepening about 6 of the original surface pits, the original 30 metre deep pits. We combined a few of them, turned it into 3 deeper sulphide pits and went down to about 100 metres depth. And currently we have a couple of small surface cutbacks, but our underground focus continues. The company is Northgate Minerals. It's a Canadian company, and they purchased Perseverance in 2008. The company owns the Fosterville and Stope mines, producing about 175 to 200,000 ounces per annum, and also the Chemist South open pit or project in Canada, and that open pit finished earlier this year, and there's a large copper gold cave feasibility study, I understand, pre-feas going ahead there. They've also got the Young Davidson deposit, which is a project in its construction phase, should be producing about 150,000 ounces starting I think next year. So a couple of good projects in Canada. And more recently, we've been the target of a takeover by Orebody Gold, and that's going through the motions as we speak, so stay tuned on that one. Sounds good, Orebody Gold. Sulphide ore, this is the big picture. As at the start of this year, we had 3 million tonnes of reserve at 4.5 grams for about 400,000 ounces, which translates to 4 years life of mine at about 100,000 ounces a year. Development is currently 650 metres underground, and stoping is about 600 metres underground. So I'll try and give a bit of an idea where we are. So there's the 3 sulphide pits that we made deeper between 2004 and 2008. Put our first portal in there and our second portal in there. And basically we took out the Falcon Orebodies underneath the Falcon pit first, and then Phoenix progressed down. We've got the Ellesmere and the Vulture Orebodies, and Harrier to the far south. Now, as far as reserves go, about 50% of our reserves are in the Harrier Orebody area. And you can see the green there is where the decline is, and we're basically hitting about this point here as we speak. So we're in the drill out phase of this area, and we've accessed a couple of the upper areas and mined those out. So 50% of our reserve sits there. About 5% fits in these couple of areas here, the Vulture and the Ellesmere underground ore bodies. That's mined out earlier in the year, and we're currently 2/3 of the way, or half the way of completing Vulture. Falcon was completed in 2009, say. And Phoenix is where the main game is. So above that point there, 30% of our reserves remain, and below that about 15% of our reserves remain. Now there's a distinct change in ore body geometry there, and I'll go through that a bit later under the mining methods section. As far as the situation for 2011 goes, so this year, Our mine plan was 710,000 tonnes per annum from underground at 4.8 grams for about 110,000 ounces, which is equivalent to about 45,000 tonnes per month of production ore. We're looking to complete 8,600 metres of development, 715 metres a month, that is, contributing about 14,000 tonnes of ore. And the Harrier pit and John's pit cutbacks were in our mine plan as well. I'll go through those in a second. The fleet consists of 4 jumbos, a couple of long hole drills, K-bolter, a couple of shotcretors, and some pretty big mechanised gear. So far, we're pretty happy with where we're sitting. We've completed 5.8 kilometres of development versus 5.7 planned, 512,000 tonnes of ore mined versus 500 planned, 82,500 ounces mined versus 76,500 ounces, so we're in a great place. And as far as produce goes out of the back end of the mill, 69 and a bit versus 68 and a bit. So we're up on ounces produced this year. And we've also completed one of those 2 pits that we had in our mine plan. So it's a good time to be outperforming, I guess, or at least above our targets, 2% up when the gold price is through the roof. I think year to date, as of last month, we were getting about $14.25 for every ounce that we sold. And last month we received $1,750. So you can see straight out that they help margins, and it's a good time. And I'll just show this in Dutchy. Sorry, I stole this from you. So this is the graph. We're in a pretty good spot there on the production graph, and there we are, Fosterville. So I like to think we're in the second quartile, even though they've put us in the third quartile there for cost per ounce. Here's a surface view, obviously. 2 lines of load that I was talking about earlier. We've got the Fosterville line of load here and the Robbins Hill deposits out here. They're the sulphide pits we originally mined. To the south, we've got a cutback in Harrier, which we've completed, and a cutback in Johns, which we've just commenced. And next year, to augment our underground mining, we're looking at another cutback at the north end and some potential future cutbacks at the far north as well. About half the historic ounces of those 300,000 in the early days were produced on each of those loads. So plenty of potential. Here's the pit, Harrier pit that was mined, so completed in August of this year, 42,000 tonnes at 2.9 grams for almost 4,000 ounces. That was the surface scratchings there at the start when we started removing the topsoil and getting into a little bit of rock. You can see here a view from the south end of the pit from a lookout. You can see the old pit, which was the original Harrier sulphide pit, was mined, and we mined an 80 metre cutback at the south end of the pit. About 80 metres length and 80 metres depth as well to get down to sulphide. Just a couple of pictures of how it all looks. Here's the view from the other end of the pit, looking to the lookout was up there, so you can see quite a bit of gear in a small area. And there's the final cut down the bottom there. So a good effort by everyone to get to the base of the pit, and there she is in conclusion. You can kind of see here a little bit of a poor area, poor ground, and if I left that photo open, you would have seen other areas where the pits give us a bit of grief. We manage it, but we have some wall issues, and this extension was completed with minimal wall issue, so as a good result, gives us a bit of confidence to mine future pits. There's a few issues on site that I'll briefly discuss. One of those is water management, and I guess that was highlighted earlier in the year with the wet weather that we had. We get a lot of water off-site for our milling process, and we've only got so many cups to put that water in. With some of the old pits, those 26 pits I was talking about earlier in the year, and even now, we find ourselves in a situation where quite a few of those water holding areas are close to capacity. So one of our ongoing concerns and an issue is managing that water, whether we move it from cup to cup or try and freshen it, I guess, through a reverse osmosis plant. We're in the process of hiring to try and recover some of that water and reuse it. That's one of the issues we're dealing with at the moment. Otherwise, we're fairly close to the community, even though we're not in the heart of Bendigo. We're 20 kilometres to the northeast. There's a township nearby called Axdale, and Fosterville itself there's houses within 500 or 600 metres of the mine site. They hear everything we do, whether it's the surface mining, so we work closely with the community to let them know what to expect, I guess, and work through that. And even underground blasts, they hear and feel as well. So we put in noise abatement bunds, and we put dampeners on our trucks, etc. So when we haul to the surface, we minimise the amount of disturbance to the community. We don't haul straight to the ROM either. We haul into one of the pits, the existing pits. And then during day shift, we get another truck fleet to quite a truck fleet to haul from our mid-pit ROM, I guess, to the mill ROM. We have tailings management issues. Our RSF1, the original tailings dam, I guess, is full. We've completed a few upstream lifts and looking at other lifts to take our waste. One of the solutions that has also been backfilling some of our original pits as well, the historic pits. So in-pit tails is a project, and there's a couple of photos on that later. But of course, by backfilling the pits, we reduce some of those cups that hold the water as well. So it's a bit of a juggling act there. Ground conditions can make things difficult at the mine as well. I'll go through that briefly in a second, but we've got squeezing ground. It's very weak out there. I didn't get to Ballarat, but I don't think it's as weak as Ballarat, but I did get to Bendigo, and it's a bit worse than the ground conditions at Bendigo. So we'll put in some of our tunnels, some of our development, and it can squeeze quite substantially, so we have to allow for that, and I'll touch on that in a second. Another issue is ore body delineation. We've got a plunging ore body. I think the original days was 18 degrees or so to the south. There you are. 18 degrees or so to the south, and getting quite deep, around that 600, 700 metre mark. We drill at 25 metre spacings to get to indicated pre-mining, and it's hard to do from the surface. So the early days didn't provide for any additional drill platforms, but more recently we've put extra drill platforms here, up here as well, and even over, we're putting another drill platform in there to try and delineate it ahead of mining. So that gave us quite a bit of grief in the early days where we didn't quite know what to expect out here, and it affects some of the mining decisions that we made. But by getting drilling in front of ourselves now, and also the geologists put a lot of effort into it with their interpretations, and even sludging all of our production holes when we go in there to mine it to give us a better understanding. That's certainly give us some positive benefits when it comes to recovering the ore and reducing dilution. So this is looking at the ground condition issue. I'll go through a couple of initiatives that we've had at the mine. This one was the MD bolt. The drives themselves, some of our old drives, you can kind of see a bit of deformation there. That's the shoulder of the drive buckling in, plates popping off, cracking into the ground. No rock falls. We do our best to avoid rock falls and make sure we rehabilitate the ground beforehand. But this sort of movement and damage to ground support lends itself to rock falls. You can see it's probably hard to see there, but it's very poor ground blowing out in the backs of the drive whilst mining. So it's a sort of ground that quite weak. It's like Play-Doh. Unfortunately, we're 500 to 700 metres underground. Squeezes, you get 100 or 200 millimetres of deformation on each wall. Starts to crack the ground support and render it ineffective. So we had to look at, we worked with one of our suppliers to create a bolt that lent itself to our ground. We needed a bolt that moved with the ground, was easy and efficient to install with the fleet, saved time and money, and was sufficient high capacity and of safety to work in our requirements. Just there you can see that was actually a 300 millimetre step in the floor when our ground moved in one of our shallow drives. So here's the MD bolt that we came up with one of our suppliers. Over the last couple of years we've developed this. It's called the mechanical dynamic bolt because it's mechanical, and dynamic means it moves essentially with the ground. It's essentially one big dyno bolt. You've got an outer shell, which is a standard split set. All those that have been underground know the standard nails you put in, the C-section that you jam in. Essentially it's got a solid bar in the middle with a expansion shell at the bottom. So drill a hole, install the bolt, spin it up, and it tightens like a dyno bolt. So for the operations guys, they love it because it's quick and easy to install. For us in the technical department, we like it because it provides an additional level of safety. It moves with the ground. It means we don't have to go back in there and rehabilitate the drives afterwards, which slows everything down and costs us money. So that's one of the solutions we've come up with. The bolt itself is high strength, 22 to 27 tonnes effective steel capacity. The split set's around 15 to 18. High yield, it slides at about 19 to 22 tonne and slides it through the test work at over 150 millimetres. And it's one pass, like I said. It installs like a friction bolt only with a twist. So that's one of the things we've come up with. We currently install about 2,000 of those a month, and we're the only site in Australia to use those. But we're just perfecting it, I guess, before Sandvik, the supplier, goes out and sells to others. Some of the mining methods we've had to come up with to deal with our conditions. In the Falcon, which is one of our northern ore bodies, there's a section in a minute, and I'll explain it a bit better then, but you can see from that picture, there's a pretty sharp delineation there between the ore on the right, and that's black shale waste in the hanging wall. That's the Fosterville fault heading down there. Now that's very poor carbonaceous ground, so poor ground's bad for mining because it falls in on you, and carbon's bad for the mill because it's pre-gromming when it goes through the circuit. So we had to come up with a different way. Instead of putting the tunnel in, which we did here, and then stoping it out into an open void and trying to recover the ore cleanly, we went for a different method called the sub-level under rock fill, the slurf method. So here's the pit, several levels underneath it, 4 levels at the time, one up here and a couple more. You can see they're all the production rings there. So each one of those lines is essentially a production ring that was drilled out and fired individually. So the method was essentially development in the footwall of the ore body, a couple of accesses out to the ore body, and then develop along the ore body. And you can see here it's essentially retreat into the centre and fire a big shot in the middle and try and block it out of a drive from the footwall. Ideally, we broke the first shot into the base of the old pit, which was backfilled, and we drew the waste rock in behind it. So we fired that, we recovered the ore, and the void that was left by us pulling the ore out was where the waste rock was drawn down. So it essentially supported our hanging wall. So it stopped that section there from falling into the ore section. So we did that fairly successfully for the first few years of the mine life, and you can see we had several areas, and we basically moved from retreat into a closeout pillar. So that was the slurf method that we came up with in the early days. Then in Phoenix, which is probably in the early days about 70% of our reserve. Here's a geologist, not to scale cross section. It's fairly generic. It's in the Phoenix lode. We've got the the Fosterville fold on the hanging wall, Phoenix fold on the footwall, and a few mid-splay faults between, and lower Phoenix and a few other faults down here with that offset syncline hinge. You can see there that things vary depending on where you are. In the upper areas, the ore body was pretty simple. Had a base footwall fault, dipped at 70 degrees, was 5 to 8 metres thick, and we could put a tunnel in here, and here, and fire out the bit in between with just an open stope method. So basic uphole bench stoping was the early days of the mine, I guess. Then we moved down to some of these thicker areas, a little bit more complex, and it was a little bit too wide to mine with a drive along the ore body, so we had to put in a couple of drives. We put development out here, drove across into it, and then fired out holes that are 20 metres wide by 20 metres long by 20 metres high. So we took out bigger chunks of ore, and that's the transverse stope section. And in there we brought in cemented rock fill as well, so to try and recover close to 100% of our ore body. In some of the early days in the uphole benching, we'd put a 15 metre panel, leave a 5 metre rib, take a 15 metre panel, so you're leaving 20% of your ore behind. We also use a method called underhand shrink stoping. So in the closeout zones where you head out to the ore body in an access, you head north and south along the ore body, and then you stope back into the centre, you get to a point where the ground conditions have deteriorated, it's hard for our blokes to get in there, and you can't take it in small chunks. You've got to take maybe a 15 or a 20 metre section. So where several of those levels line up, we fire that out, fire out the next level, and then fire out the bottom level ring by ring. And what that does is it essentially it works like the Falcon cave I discussed before, where the ore draws down and the waste rock falls in behind it. Because we're opening up several sub-levels at a time, several stope levels, the stability of the hanging wall deteriorates and essentially falls in behind the dirt that we pull out. So we use the same concept in our closeouts as well to maximise recovery. That's difficult to explain, so if anyone's got any questions on that, hit me up later. Otherwise, we've got the FGM underhand chain caving method. I won't abbreviate that, but we came up with that to try and work out how we were going to mine this section of mineralisation down here, this section of ore. About 50% of that section dipped at less than 40 degrees. Now we can all understand, if we throw a pile of rocks on the ground, it rills out at about 37 degrees. So if you fire something underground to draw the rock out, it rills at around about 35 to 40 degrees. Once you start going shallower than that, you can blow something up, but it doesn't move. So we had to find a way to try and mine 50% of our ore body below 40 degrees. Now, one of the ways we're going to do that is this method. And it's basically drive, shallow ore body. We've got our drives from being, say, 15 metre space. You can imagine 15 metres in a steep ore body is pretty easy. The drill holes between them are 15 metres when you're vertical or at 70 degrees. Once you start laying it over to a 35 degree ore body, all of a sudden the drill holes are too far for us to drill anyway with our current fleet, and it's too hard to recover it. So we ended up bringing our sub-levels down to bring the drives closer together and only have 15 metre holes. And our idea is we'll only fire it in 2 or 3 ring chunks. So we'll try and fire at that dirt that's between it, and that dirt will fire into the drive. So we don't expect it to run, we don't expect it to reel down, which you'd normally do in a conventional stope because it's gravity fed. So we'll essentially fire the ore into the drive, bog it out. When we can't get any more, we'll fire the next lot. So it's essentially a cave without requiring a cave, where we're just trying to recover. We're trying to use blasting, I guess, to move the dirt for us rather than gravity. So that's that technique, which is going to be a lot of fun, and we're exposing that sort of ground now. Okay, a few pictures, just very briefly to show you where we're up to. This one's out of focus, but it was a beautiful photo showing you the stope. It looks like it's carved out with a knife with the footwall and the hanging wall there. So that's the earlier Phoenix style stoping, and that was the good old days. It's not that easy anymore. Phoenix stope there as well. Some of the voids we made. Drives are the stope widths are generally 5 to 8 metres wide and 15 metres high, as you can see the drive width there. We also use CRF, that's that photo there, and sorry I should have shown you a second ago, that's the cemented rock fill. So we mine top down, so we fire a stope, backfill it with cemented rock fill, then we mine underneath it and take it out to try and maximise that recovery. Not a very good picture, looks good on my computer screen, but so there you go, some of the uphole voids in Phoenix. And there's a transverse stope, so this one here is about 20 metres wide by 20 metres across, I guess, if you put it that way. And we're taking out a stope that's 20 metre high, so that's a 10 or 15,000 tonne void sitting under the cemented rock fill. So you can see it's worked pretty well for us. Us and Stall and I think Cobar are the only ones that really use this CRF approach. And you can see there, taken from one side of the stope, there's the CRF sitting from a stope above us, and we've mined out the void underneath us there. Alright, that's what a typical level plan would have looked like in the early days. Decline access, that's our ventilation circuit, access out to the ore body, footwall access, and there's the transverse zone. So we create a bit of a T-stub out on the ore body, take a slot out and fire the rest in. And there's a north and south sill drives there, longitudinal stopes out there, just the uphole benches. Alright, that's everything I said. Now that's a quick isometric view of the shallow part of the ore body, which is that lower Phoenix area, the FUCC zone in the Fosterville one hand. Grades, don't look too much into the grades, they're diluted ore grades there based on the January reserves, but you can get an idea that it is fairly flat through there anyway. We're currently down at the 4,500 level. Should have got these back there, haven't I? Now there's some of the initiatives from the metallurgy department on site over the last couple of years. That's the Fosterville pit, in-pit tails going in. And Vince will be happy to answer anyone's questions on those later on. We've filled up Fosterville pit, and we're currently filling Hunts, which is the next one to the north in the long line of pits. A couple of other initiatives more recently has been the concentrator regrind. That's why I quizzed you during the break. It's added a couple of % recovery to the circuit, and certainly numbers of 86 to 80% recoveries of late were numbers that we rarely heard of in the early days. So the guys have done some great work there, and also the heated leach circuit has improved our recoveries as well. And finally, I'll just touch on a project that was completed earlier this year. It was the Harrier vent shaft, halfway out to the Harrier Orebody. I don't know if you noticed, there was a vertical line, a 350 metre deep by 3.8 metre diameter when it's finished vent shaft. We used a couple of new techniques, or particularly this technique here, to install it. We used a piling contractor. I'm not sure if you guys have seen the piling contractors on the side of the road banging in the piles. They also auger out large diameters as well. So this is some of the gear that they had on site. That's a big 1.8 metre diameter bucket attached to this sort of fixture here, a Cali bar. Another photo shows you looking top down on that. So you can see it's got a long bar along the middle, attaches this to it, and essentially puts a 1.8 metre borehole for as far as you want to go with it. And it's got a bit of a bucket attachment to the bottom to remove the dirt. And the next photo shows what happens after that. So there's the bucket down the bottom in that 1.8 metre hole, and then it just simply reams out layer by layer until it gets to the diameter you're chasing. It can go out to 6 metres. So we had some very poor ground there for the top 40 metres. We put in an 8 metre concrete pre-sink in, which essentially dug out with an excavator, and then we boxed up this circle and filled it with concrete. It's very expensive, so 8 metres is far enough. And then we put this 35 metre deep piling shaft in. So it worked well for us. We remotely sprayed that with fibrecrete to put our ground support in and keep the rock stable, the wall stable. And then we drilled a pilot hole down to 350 metres where our development was for the mine, and we attached this 4.1 metre raised bore head, pulled that to the surface, and that's what it looked like when it was supported towards the end of the project. Quite a few services there, and a pretty neat project. So all up, that was a good project that, like I said, was completed earlier in the year. So that's a bit of an update of where we're at, guys. Thanks for having me.